Okay, so before we jump into what convolution is and signal theory, I'm gonna define two topics. One is a signal. What is a signal and what type of signal do we use? And the second one is how do you represent an image? Yeah. Now in signal theory, here you have time and here you have the function of time, and this what you see here is a signal. I think it's easy to understand and to recognize. But what this is an analog signal, and it's continuous. Now a computer cannot accept analog signals. We have to digitize the signal. And how do we digitize? Well, we sample the signal. How does it work? Well, you have here your signal. Yeah? Let's say this is the first one. We're gonna take samples at certain time intervals. Yeah? And then we put them here. So this is the first one. The second one a bit higher. The third one a bit lower. Even lower the fourth one. And then it goes slowly up again. Yeah. So this is the digital version of this signal. And we call this here now n, and this is f of n. Yeah? For discrete signals, we will use this small n, but it's actually time, right? So these are specific impulses of a certain height over time. So this is a discrete digital signal. All right. So how do we represent an image? Well, this is a grayscale image, and we have N1 and N2. Yeah. And then we have. So this is your image. It has 28 by 28 pixels, and the values you have here is the intensity. So intensity should be between, actually it's 8 bits. You have 8 bits to give the intensity. So that means that you have 2 to the power of 8 options. Yeah, so that's 256. So your options of intensity go from 0 to 255. Yeah. So here, for example, this could be x 28, 28. That's that pixel. Could be the value of 150 in terms of intensity. Yeah. Right. So this 150 would be the number here. So here you have actually a matrix with values, and the values are the intensity of the pixel at that position of the image. So that's for grayscale. All right, when we look at a color image, we can again look at x28, 28 equals. Well, in this case, this is a scalar. It's just a number. Yeah, but in this case, this will be a vector. Yeah. This will be a vector of xr 28, 28, and then x green 28, 28, and then x blue 28, 28. All right, and this is actually your vector. So this is equal to x 28, 28. And here you have your 3 channels, red, green, blue. Yeah, so now we know what digital discrete signal is, and we know how to represent images.